Important problems on Bayes' theorem. A bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the two bags is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from the first bag. So this is one of the problem on Bayes' theorem. Here, so there are two bags. So say, take them as event E1, E2. Let event E1 select bag 1, E2 select bag 2. Probability of selection of bag 1, that is probability of E1, is equal to 1 by 2 because there are two bags. Selection of bag 1 out of two bags, probability is 1 by 2. Similarly, probability of selection of second bag, probability of E2 is also 1 by 2. And now another event is already given, that is the one of the ball is drawn from any one of the bag. So the drawn ball is red, it is given. So take it as event A. Let event A drawn ball is red. Now find probability of drawn selection of bag 1 and the drawn ball is red, that is probability, conditional probability of E1 given A has occurred. So is equal to number of red balls in bag 1. So it is given 4 red balls divided by the total number of balls in bag 1. So 4 red and 4 black, total 8 balls. So 4 by 8, that is 1 by 2. Probability of selection of bag 2 and the drawn ball is red, that is conditional probability of E2 bar A. So number of red balls in bag 2 is 2, total number of balls in bag 2, that is 2 red and 6 black balls, total balls 8, 2 by 8, so that is 1 by 4. Now, by using Bayes' theorem, this can be written as, so the required probability is the drawn ball is red, that is from bag 1. By using Bayes' theorem, this can be written as conditional probability of event A given that E1 has occurred, that is conditional probability of the drawn ball is red, that is from bag 1. Probability of A E1 has occurred is equal to, by using Bayes' theorem, probability of E1 into probability, reverse probability of required probability, that is probability of bag 1, that is probability of E1 given A has occurred, divided by, in the denominator, total probability, probability of E1 into conditional probability of E1 A has occurred plus probability of E2 into conditional probability of E2 given A has occurred. So substitute the values 1 by 2 into 1 by 2 by 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 4. So that is, after simplification we get 2 by 3. The required probability is 2 by 3. So that is, the drawn ball is red, that is from bag 1 is 2 by 3. Next problem. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Find the probability that it is actually a 6. So here, take the event E, 6 occurs, and complement of E dash. So take complement of E, 6 does not occurs. E and E dash or E complement are two events. Probability of event E means 6 occurs. When a die is thrown, probability of event E means probability of 6 occurs. So that is 1 by 6 because there are 6 numbers in a die. So 6 occurs. So there is 1 divided by total number of elements in the sample space. 1, 2, 3, 4, 5, 6. So 6. Probability of 6 occurs when a die is thrown, 1 by 6. Probability of 6 does not occur. So this is E dash is the complement of E, event E. So therefore, probability of 6 does not occur. Is the complement of 6 occurs. So therefore, probability of complement 1 minus probability of E. E complement is the E dash is the complement of E. So therefore probability of E complement is equal to 1 minus 1 by 6. We know probability of A complement is equal to 1 minus probability of A. So therefore 1 minus 1 by 6, that is 5 by 6. Probability of 6 does not occur, 5 by 6. Now take another event. The person reports 6. So when a die is thrown, the person reports it is a 6. So that event is taken as event A. Now find conditional probability of the man reports 6, that is event A, given that event E 6 occurs. The man reports 6, it is also 6 in the die. Okay, so it means it is probability of truth. He says it is given, he speaks truth 3 out of 4 times. He speaks truth 3 out of 4 times. It is probability of truth, that is 3 by 4. He reports 6, probability of he reports 6, given that 6 occurs in the die. So both are matches. So therefore probability of truth 3 by 4. Next, conditional probability of event A, that is he reports 6, given that 6 does not occur in the die. So that is complement of this event. Therefore 1 minus probability of this one is 3 by 4. So 1 minus 3 by 4, that is 1 by 4. It means probability of E reports 6, but it is not 6 in the die. That probability is 1 by 4. Now the required probability, what is to be find? Find the probability that it is actually a 6. So required probability, conditional probability of 6 occurs, E reports 6. That is to be found. This can be written by Baye'S theorem. This can be written as probability of here E, probability of E given A has occurred. It is to be found. So probability of E into the reverse probability of this one. So probability of condition probability of A given A has occurred by probability of E into condition probability of A given A has occurred plus probability of E complement into condition probability of A given E complement has already occurred. So this is by using Baye'S theorem we write like this. So substitute the values probability of E, probability of condition probability of A given E has occurred 3 by 4, same plus probability of E complement into conditional probability of A given E dash has occurred. So simplify, we get 3 2s are, so 1 by 8 in the numerator divided by same 1 by 8 plus, so this is 5 by 24. So by taking LCM, so 3 2s are, so 2 into 4 8. Okay, so by taking the LCM and simplify the denominator, so we get the answer is so 3 by 8. 3 by 8. So take LCM in the denominator and simplify. We get the required probability, that is the conditional probability, the probability of event E, that is 6 occurs, and the man also reports 6. He is 3 by 8.